projects in Vidarbha. We'll shortly start with the session, so I would like to request you all to please get settled down. And within a few moments, we are going to get started with the very first session of the day, which will be on coal gasification. Thank you.
Clean fuel technologies assume critical importance. This forum provides a valuable platform to exchange ideas, share experiences, and explore practical pathways for advancing coal gasification projects, particularly in the Vidarbha region. We had a similar dialogue at Advantage Vidarbha, which became a catalyst for transformative growth, leading to investment of rupees 15,000 crore in the Vidarbha region. We believe this momentum will continue to inspire industry leaders to collaborate, innovate, and play a pivotal role in shaping the future of coal gasification sector in the Vidarbha region. With your kind permission, I would now like to take this opportunity to formally introduce the distinguished dignitaries and eminent panelists who have graced this occasion with their presence today. Dr. Vijay Kumar Saraswat, member Niti Aayog. Dr. Vijay Kumar Saraswat is a distinguished scientist with vast experience in defense research spanning over several decades. He retired as Secretary Defense Research and Development Organization. After decades of government service, he holds a PhD from Osmania University and an ME degree from the Indian Institute of Science. Dr. Saraswat has had an illustrious career and is credited with the indigenous development of missiles such as Prithvi, Dhanush, Praar, and Agni 5, the two-tiered ballistic missile defense system, the initial operational clearance of light combat aircraft Tejas and nuclear submarine INS Aryant. As the Homi Bhabha Chair Professor and Consultant to IOCL R&D, Dr. Saraswat evolved a roadmap for the development of alternative energy systems such as clean coal technologies, high-efficiency concentrated solar power systems, and bioenergy and hydrogen-based economy. He is currently Chairman of Research Advisory Council, IOCL R&D. As member Niti Aayog, Dr. Saraswat, the Methanol Economy Program for Transportation, Energy Generation, and Production of Chemicals and Fertilizer, etc. To this end, production agencies, academic institutions, and petrorefineries have brought together to further the cause as part of initiative M15 gasoline blend, methanol cooking stove, methanol-fueled propulsion for inland waterways, and methanol-fueled gensets are being introduced in the country. At the academia and industry levels, R&D in the gasification of high ash content India coal has been undertaken. He is the recipient of many awards, including the Padma Shri and Padma Bhushan 2013. He has been conferred an honorary doctorate by more than 25 universities, most recently Dr. Dasapa, Professor, Center for Sustainable Technologies, Indian Institute of Science. Dr. Dasapa is advisor at the Interdisciplinary Center for Energy Research, Indian Institute of Science. His research focuses on combustion of solid, liquid, and gaseous fuels. He has over 220 publications and more than 30 patents with extensive experience in global technology transfer and policy influence. His current work on producing hydrogen from biomass for PM fuel cell application is a novel process with significant potential for renewable energy, hydrogen, syngas, and biofuel production. He is leading a joint demonstration project with Indian Oil Corporation to set up the first green hydrogen from biomass PM fuel cell bus application. Professor Dasapa has been recognized among the world's top 2% most influential scientists for 3 years consecutive. We welcome you, sir. Piyush Kumar, MD, Bharat Coal Gasification and Chemicals Limited. Dr. Piyush Kumar is Managing Director of Bharat Coal Gasification and Chemicals Limited and Director of Coal Gas Limited. He is Head Coal to Chemical Department of Coal India, Kolkata. He worked as Director Technical in Ministry of Coal from 2013 to 2020 and served as Government Nominee Director in the board of several companies such as MECL, SECL, CMPDI, BCCL. We welcome you, sir, to the forum. Balasaheb Darade, Founder and Managing Director, New Era Clean Tech Solution Private Limited. Balasaheb Darade is an award-winning entrepreneur, public policy expert, and execution-focused global leader recognized for shaping high-impact clean energy and decarbonization initiatives. He operates at the intersection of energy security, sustainability, policy, and industrial transformation. As founder and managing director of New Era Clean Tech, he is leading one of India's most strategic clean energy platform of $4 billion at over a 1,650-acre land. Integrated gasification, clean fuels, fertilizers, SFA fuels, and CCUS industrial ecosystem in Maharashtra. We welcome you, sir. Once again, I extend a very warm welcome to all our distinguished dignitaries, esteemed panelists, and valued participants. We are honored by your presence and look forward to an insightful and meaningful discussion. Thank you so much.
Thank you so much. And yes, with that, as I already told you all that today, for this panel discussion, we are having Dr. Nikhil Sardesai, sir, who is going to be the moderator of this session. So yes, without any further delay, let's move towards the next session, or towards the session for which we all are present. May I now please request Dr. Nikhil Sardesai, sir, to start the session.
Good morning. Yeah. So good morning, one and all. I welcome you all to Vidarbha, to Advantage Vidarbha session on coal gasification. India is positioning coal gasification as a strategic bridge between energy security, industrial growth, and clean coal utilization. This discussion will explore the business intent, the business viability, technical realities, the regional development opportunities, and the global lessons learned from the various countries. So now I welcome Saraswat sir to kindly address the session by his keynote.
Can somebody help me with connecting my presentation? आपकी केबल यहाँ तक आती है?
You have a cable?
Have a connector. Okay. I don't know which is your connector. This, I think most probably this. This goes into my. No, first you tell me whether this is your cable. केबल आएगा यहाँ तक? अरे बेटा इधर आओ, यहाँ से इसको कॉपी कर लो अपने कंप्यूटर पे, या प्रेजेंट मैं यहाँ से चेंज कर दूँ। हाँ इस पे ले लो ना, पेन ड्राइव इसमें नहीं आएगा, इसमें आएगा, ये इसमें नहीं आएगा, नहीं आएगा, नहीं आएगा, इसमें लगाओ, इसमें लगाओ, ऐसे पावर खोल दूँ इसको
कॉपी कर लो। इसको मैं कॉपी कर लूँ।
या इसको लगा के इसमें प्रेजेंट करिए। आपका स्लाइड चेंजर है? स्लाइड चेंजर I'm too short for this dice. I'm not going to use this. कुछ राइजर है तो लंबे लोगों के लिए बनाया आपने, छोटे लोगों के लिए नहीं बनाया। हो गया, लगाओ। हाँ ठीक है, फुल कर दो, फुल स्क्रीन। गो टू शैम्पेन ग्लास। अरे शैम्पेन ग्लास पे जाओ, नीचे है नीचे। हाँ नमस्कार, गुड मॉर्निंग, सॉरी फॉर द टेक्निकल डिले। मेरा नाम आप लोगों ने सुन लिया, मैं डॉक्टर विजय कुमार सारस्वत हूँ। हाँ, काफ़ी 2 साल पहले भी मैं यहाँ विदर्भा में जब इस तरह का प्रोग्राम हुआ था तो आप लोगों के समक्ष कुछ मैंने प्रेजेंटेशंस किए थे कोल गैसिफिकेशन पर ही। 2018 से और आज तक करीब करीब 7 साल हो चुके हैं। कोल गैसिफिकेशन का जो एक मिशन हमारे ऑनरेबल प्राइम मिनिस्टर ने हमको दिया था वो ये था कि हिंदुस्तान में कोल गैसिफिकेशन होना चाहिए। उस समय नीति आयोग में और कोल मिनिस्ट्री के साथ मिलके और देश के काफ़ी बड़े बड़े वैज्ञानिकों के साथ मिलके एक कमेटी बनाई गई और उस कमेटी में करीब 2 साल तक काफ़ी डिटेल डिस्कशंस हुए कि किस तरह से हिंदुस्तान में कोल को गैसिफाई किया जा सकता है। क्योंकि एक इस तरह की भ्रांति थी, एक धारणा थी कि इंडियन हाई एश कंटेंट कोल कैन नॉट बी गैसिफाइड। और ये धारणा केवल मिनिस्ट्रीज में नहीं थी, ये एजुकेशनल इंस्टीट्यूशन में थी, इंडियन एकेडमी में थी, इंडियन इंडस्ट्री में थी। और इसका फ़ायदा बाहर के मुल्क की जितनी भी कंसल्टेंट कंपनीज थी वो पूरी तरह से उठा रही थी। एक सबसे पहला प्रयोग हुआ था, जिंदल स्टील्स ने एक प्लांट लगाया था लुर्गी, सासोल, और वो प्लांट काफ़ी साल लगने के बाद भी नहीं चला। तो वो एक उदाहरण ऐसा पेश किया गया कि क्योंकि इंडियन ऐश है, ऐश कोल है, इसलिए ये टेक्नोलॉजी इसके लिए सूटेबल नहीं है। अनफॉर्चुनेटली किसी भी संस्था ने, किसी भी एजुकेशनल इंस्टीट्यूशन ने, किसी भी नेशनल लेबोरेटरी ने इस विषय को गंभीरता से नहीं लिया, और जो रिसर्च उसके ऊपर करनी चाहिए थी वो बहुत नाम मात्र की रही। अगर आप देखेंगे, डॉक्टर दासप्पा यहाँ हैं हमारे साथ, जिन्होंने इन सब विषयों में काफ़ी काम किया है। तो मैं आप बताऊं कि 2006-05 तक हिंदुस्तान से हाई ऐश कंटेंट कोल गैसिफिकेशन पे हार्डली एनी पेपर्स वर देयर। उसके बाद हम 2018 से जब हमने इसके बारे में काम शुरू किया तो हमने कहा कि ऐसा हो ही नहीं सकता, ये ऐसी टेक्नोलॉजी है ही नहीं कि इसको नहीं कर सकते हैं। पर उसके साथ साथ चाइना में कोल गैसिफिकेशन के ऊपर 2015-16 से काफ़ी काम हुआ, और हमारे पास न्यूज़ ये आने लगी कि चाइना में बहुत सारे कोल गैसिफिकेशन प्लांट लगे हैं, और ये भी न्यूज़ आ गई कि शेल जैसी कंपनी ने प्लांट लगाए हैं, इस कंपनी ने लगाए, काफ़ी विदेशी कंपनीज के नाम आए। तो हमारे देश के काफ़ी इंडस्ट्रियल पीपल गए और देखा कि वहाँ पे कोल गैसिफिकेशन प्लांट काम कर रहे हैं, और वो तरह तरह के प्लांट थे। कोई कहता था एंट्रेन बेड प्लांट है, कोई कहता था सर्कुलेटिंग फ्लूइडाइज बेड है, और कोई कहता था नहीं वहाँ भी हाई एश कंटेंट कोल से काम चल रहा है। तो हमने कहा अगर चाइना में हो सकता है तो हमारे यहाँ क्यों नहीं हो सकता। तो एक विशेष तौर से ये कार्य शुरू किया गया। तो आज मैं आपको ये बैकग्राउंड इसलिए दे रहा हूँ कि हम लोग इस भ्रांति के कारण एक गिव अप वाली स्थिति में रहे, और गिव अप वाली स्थिति होने की वजह से आवर कंट्री हैज़ नॉट बीन एबल टू कोप विद द रिक्वायरमेंट ऑफ क्लीन कोल टेक्नोलॉजीज। तो आज मैं आपको एक थोड़ा सा टेक्निकल कम कॉमर्शियल डिटेल देना चाहूँगा, एंड आई सी लॉट ऑफ स्टूडेंट्स आर देयर, फॉर देम प्रॉब्ली इट मे बी स्लाइटली बियॉन्ड देयर अंडरस्टैंडिंग, बट आई विल ट्राई टू मेक इट एज सिंपल एज पॉसिबल। हम कोल की क्यों बात करते हैं? वाई आर यू टॉकिंग अबाउट कोल? वी आर टॉकिंग अबाउट कोल because there is a energy demand. The energy demand has tripled over the last कौन सा है भाई? ये है या ये है या ये है? काम नहीं करता। आप भी कर दीजिए, मैं बोल दूंगा, आप करते जाइए। नेक्स्ट स्लाइड। तो एनर्जी डिमांड के कारण से इलेक्ट्रिक डिमांड अंडर बिजनेस एज यूजुअल केस in the scenario of 2047 will be to the tune of 600 terawatt hours. Total energy demand by 2070, or 2070 has a special significance because we have made a commitment to the world that India will be net carbon zero by 2070. मतलब हमारे देश में कार्बन कंट्रीब्यूशन जो है ज़ीरो हो जाएगा। पर उस समय हमारी जो एनर्जी डिमांड इज गोइंग टू बी 18,900 to 22,300 terawatt hours. And all our simulation, all our studies with all experts indicate that 29% primary energy even at that time will be produced from coal. So it is obvious that if we have to become net carbon zero, we cannot burn the coal the way we are burning today. If we burn the coal the way we are burning today, we cannot be net carbon zero. And hence, there has to be a paradigm shift aiming towards increased efficiency and cleaner approaches so that we can achieve the net carbon zero while using the coal itself. And hence, the technology like net carbon zero. Next. All of us know this graph shows that the total estimated coal reserve of India is approximately 400 billion tons as on 1st April 2025. Out of that, 220 billion tons is in the proven category. Or India has a historic milestone of 1.04 billion tons coal production in the year 24-25, thanks to our Coal India, thanks to our coal ministry and all the private industries who are involved in the mining. That means we have a target of something like 1.5 at an annual growth rate of about 6 to 7%. Our import, we used to import a lot of coal. Can you imagine? India having so much of coal, but we were importing almost 26 to 27% coal from Indonesia, Malaysia, and all these places. The reason, when we discovered, the reason was the cost of transporting the coal from Indonesia to the thermal power plants or the steel plants which are located on the coastal region was much lower than the cost of transporting it from Odisha into those places like Tamil Nadu and so on. So ये सब बातें होने से we see that there has been a significant drop in the import, about 8.4%, which saved about 5.43 billion in foreign exchange. This graph shows, if you see all the bars, our 80% of the coal produced in India is utilized for the thermal power plants, the large one. Next one is oil, next one is gas, and so on. And energy consumption is also shown there. Basically, our energy distribution, if you say about 84% is the fossil fuel, and only 20 RE and nuclear is about 16%. So that is the kind of a distribution we have. So, coal demand. Vidarbha has got western coal fields. You have great reserve. Unfortunately, the problem of Vidarbha mining, last night we were discussing, because of the depth, I think, at which it has to be done, and some other reasons. It is one of the most, as on today, the costly process. But if you see all the sectors, cement plant, steel plant, power plant, coking coal, others, power is the highest, 808 million tons. And total non-coking is about 1289, and total is about 1376 million tons. This is the kind of a demand. And as I was mentioning to coal-based power generation, next please. Next. Yeah. Coal-based power generation will be highest, and we have to go to something like clean coal technologies. And clean coal technology is nothing but not burning the coal as it is, but gasifying the coal, and then, of course, integrating it with the carbon capture utilization so that your carbon footprint is reduced. Next, please. So what are the clean coal technologies? One is the reducing the coal consumption. That is what we are trying to do by getting it to renewable power and things like that. Reducing the greenhouse gas emissions. Use carbon capture and utilization and storage facility. Or improving the efficiency of burning coal by using what is called advanced ultra supercritical plants, where the efficiency can be as high as 47 to 48% as compared to ultra supercritical, which is in the region of 38 to 42%. And integrated with the integrated gasification combined cycle, which also takes it to higher than 48%. Unfortunately, in India, we have again worked on both these processes not in a consistent manner. As a result, these are not yet commercialized. Next one is, as I mentioned to you, the description of coal gasification. It has also not gone to the level that it can be also commercialized even today. Carbon dioxide utilization for production of chemicals and methanol, that's another one. These are the various methods which are possible for net carbon zero. Next, please. So clean coal technologies, major problems associated with the current coal-based technologies because lower efficiency, environmental loading and consequent damages. Bulk coal reserves in India are of inferior grade, non-coking coals with ash content in the region of 45 to 50%. So we need CCT with high efficiency and lower environmental impact to produce synthetic fuels, chemicals, various thermal applications, and power generation. Next, please. Now, what is coal gasification? Now, this is what children, all of you should see, because many of the other people who are present there, they know this process very well. Basically, coal gasification is a process in which you take coal, you mill it and mix it with water or slurry, you make it, and pump into a reactor where oxygen is pumped, the coal is fed there, and it is gasified with steam and so on. So you produce what is called gas, and that gas is then passed through a scrubber to remove the particulate matter. Then mercury is removed. Then there's a gas cleaning plant where hydrogen sulfide, carbon dioxide, and sulfur are removed. So you get what is called cleaned syngas, which is mixture of carbon monoxide and hydrogen. Now this carbon monoxide and hydrogen can be used as it is or in separated form for different processes like making methanol and any other thing, or syngas as it is for different applications. So this is in small the description of how a coal gasification plant works. Next, please. The coal gasification products, like we can take coal or pet coke, then gasify, create syngas. Then, say, as I mentioned to you, the moment you have syngas, carbon monoxide can be used for making chemicals, acetic acid. Methanol can be used for making formaldehyde, DME, ethylene, propylene, MMA, and also now SF. Then you can separate hydrogen, and that hydrogen can be used for refinery, fuel cell, and ammonia, and so on. And downstream, you can do many things from this. Once you produce them, you can make organic chemicals, you can make sustained aviation fuel. And if you do the Fischer-Tropsch process, ये क्या चाहिए आपको क्या चाहिए? If you use the Fischer-Tropsch process, you will be able to make diesel, naphtha, and others. Next, please. Now, what is the global scenario as far as coal gasification is concerned? This technology was developed in 1800 to generate town gas used for lighting and heating in UK. During World War I and II, Germany refined the products to produce SNG, gasoline, and diesel. South Africa is producing such products on commercial grounds. China's coal gasification program began more than 25 years back, and it has, next please, and it has scaled to almost about 300 million tons per annum of coal as of now. 75 plus coal to chemical projects across 15 provinces are under planning stage. And coal gasification there is producing ammonia to the tune of 70 million tons per annum, urea to the tons of 80 million tons per annum, and methanol to the tune of 80 million tons per annum. If you see from 2024 to 2032, there has been a significant increase, about 6.25% CAGR, and reaching to about $22.44 billion. So this is the kind of a market you can see here already. Next, please. Now, there are different kinds of gasifiers, and this is important because now, if the country has to decide what is the best gasifier, they should have a knowledge of what is the different type of gasifiers technically available. One of them is called the fixed gas gasifier. In this case, the solid fuel remains as a packed bed inside the reactor. The bed is called a fixed, and fuel usually moves slowly through the reactor. Air and oxygen, steam flow through the bed, and its advantages is it can be a top-down, updraft, or downdraft. So advantage is flow of solids is independent of the flow of gas, minimal pre-treatment of feed coal, and high thermal efficiency. But there's a disadvantage in terms of product gas contains tars, oils, and heavy hydrocarbons, and high methane content of the product gas. Then there is a fluidized bed gasifier, where the solid particles are suspended and mixed in an upward flow of gas, air, or oxygen. Fluidization gives excellent mixing and heat transfer. Advantages: uniform particle mixing, uniform temperature gradients, and higher charge recycling rate. Less gas cleanup, less capital cost. Disadvantages: particle entrainment sometimes. And as of you, worldwide, the understanding of the circulating fluidized bed is limited. There are pumping requirements and pressure drop requirements. Then there is an entrained flow gasifier, next please, which is fuel is finely ground, injected in the form of a slurry carried by the gasifying agent at a very high temperature and high speed. Unlike fixed bed or fluidized bed, there is no solid bed. Everything reacts while flying. Advantage: to handle practically any feed, syngas is free of oils and tars, and low methane production. Disadvantage is high energy consumption, high temperature and pressure. But there's a major problem here is of what is called slagging. Because what happens, this particular reactor works at a very high temperature to the tune of 1200 to 1400 degrees Celsius. And all the ash which is present there tends to melt. And once it melts, it becomes a slag. And it actually chokes the complete process. And hence you have problems of intermittency. So we did a comparison of all these key factors which were of fluidized bed, entrained bed, and fixed bed. I don't want to go into details of that, but the conclusion is fluidized bed gasification is superior because it avoids high ash melting, tolerates difficult ash chemistry. Now, why I'm saying difficult ash chemistry? Because every coal in different parts of the world has different ash chemistry. For example, Indian coal is a high content of alumina and silica, and its fusion temperatures are lower than 1000 degrees Celsius or around that. Whereas if Indian ash has, so most of the time when you use an entrained bed where the temperature is 1200 to 1400, every ash becomes a slag. Whereas in circulating fluidized bed, temperatures don't go beyond 800 degrees, so it remains as a ash only. So you can tolerate difficult ash chemistry, provides excellent gas-solid contact, and maintains stable operation under high variable feed conditions. We can discuss this in more detail. I'm not going into details of that. Next, please. Now, under these conditions, when we saw that coal gasification, the instructions of our Honorable Prime Minister has to be done, Government of India took initiatives in 2020 and set an aim that 100 million tons by 2030 should be gasified. And investment to the tune of 4 trillion rupees was identified. I see two major gentlemen and lady from Ministry of Coal present here who have been responsible for this kind of a policy. Financial outlay of 8,500 crores in three parts, 4,000 crores for government PSU, 3,850 for private, and 600 crores for the demonstration plants. Initiatives have been taken now. I'm very happy to see that all that effort of all of us together has led to 4 major or 5 major projects going on now. And Coal India is playing a major role. CIL, BHEL, CIL GAIL, CIL SAIL, Niglide, and WCL. WCL is the one which is going to be in Vidarbha region. So you can see that you are part of this initiative of the Government of India. And coal gasification projects in India will lead to hydrogen production of 15 million metric tons from the world's largest petcoke gasification plant in Jamnagar. JSPL, 1.8 million tons direct reduction DRI plant based on coal gasification at Angul. BHEL, coal to methanol plant producing 0.25 TPD methanol from high ash Indian coal. This is the one which was done as part of our initiative to set up research and development activity in BHEL, in Thermex, in IIT Delhi, and other places, which led to this. Similarly, ISC Bangalore and DST, they have done 0.75 TPD, two-stage coal gasification plant on fixed bed technology. Then Simfer, they have also done on a blown pressurized fluidized bed gasifier of 1.5 TPD. These are some of the things which have happened. This is the diagram of, next please. Yeah. This is the diagram of indigenously developed Indian coal technology. This is one case where we have taken 45% high ash coal, fluidized beds funded by Thermex and IIT Delhi together. Today the plant which is running using about 6 TPD of coal and producing about 4 TPD of carbon dioxide and 1 TPD of methanol. So this plant is operational today at Thermex, Chinchwad, Pune, which has removed that myth that Indian high ash content coal cannot be gasified. This is one demonstration that shows the capability of our country's scientists, that if we work together, we can overcome all these problems. Now, one of the major things is hydrogen. All of us are working for hydrogen today because there is a need for us to produce hydrogen as an alternate fuel. Today, world over, the only process which produces hydrogen is a syngas, that is the methane reforming process using a steam methane reforming. Today, if you use what is called the green hydrogen electrolysis, which is supposed to be the process for using, for electrolyzing water, today its cost is going to be in the region of about $7 per kg, with the following parameters: that the electrolysis efficiency is 65%, load factor is about 47%, and levelized cost of power is about $50 per megawatt hour. But as the advancement of natural gas reforming, cost would increase by 13%, while for hydrogen, if you produce from coal gasification, cost would decrease by 11% in 2030. And this is what we have said: coal gasification with carbon capture and storage, its cost will be about $3, and the breakup is hydrogen production is shown in the blue, and logistics cost is shown in the yellow, and the green shows the pricing of the remaining CO2 emissions. As you go further and further, you can make out that steam methane reforming, if you want to integrate it with the carbon capture and utilization, it will be less than this. If you take electrolysis and load factor you change and power cost come down to 0, it will come to slightly more than 2. And then in the case of electrolysis, load factor coming down and power is about $2. So you can see that there's a possibility of integrating with all the coal gasification plants which you are trying to set up today, the carbon capture, utilization, and storage. If you see that, the net carbon into the atmosphere will be 0, and the chemicals which will produce, whether it is hydrogen or it is methanol or DME or acetic acid or whatever you will produce, will be called methanol E-chemical. The advantage of E-chemical versus the gray chemical is that the cost benefit is available because the differential is to the tune of 1.5 to 1.7 times. For example, the methanol, Mr. Prashant is here, he will be able to give you more figures. I think today we have costs in the region of $250 to $275 per ton. Whereas if you go for E-methanol, you can sell it for $500 per ton. And if you go for green methanol, which is produced from biomass and then others, it will be in the region of $800. So you have a specific advantage. While your capex may be slightly more, you will be able to achieve more benefits on the long run. Next, please. Future growth of coal gas projects will depend on several factors. One is production and capital cost. competitiveness of the coal-based chemicals and government support, government policy for the supply security of domestically available coal for coal gasification industry, particularly the cost of the coal, that becomes very important, and regulation of standards for blending of coal for chemical applications, and availability of land, water, and related infrastructure. And I'm sure all these companies who are named, they have been able to muster support of the state governments, and Vidarbha region, particularly in Maharashtra, has been very, very forthcoming in supporting the project in around Nagpur. I'm quite certain that this land, water, and other infrastructure will be provided, and through this conference, there will be a significant achievement of that. So the way forward is setting up, next please, setting up demonstration plants to scale up indigenous technology. Whatever you saw in the BHEL plant or Thermax plant, it is required that we should, instead of going for 1 million ton or 2 million ton, we should first set up a 300 to 400 tons per day plant to scale up in a gradual manner through public-private partnership. For that, maybe the VGF for production of chemicals can be made use of. Setting up of plants to produce methanol to the tune of 300 to 500 tons per day. We also should introduce the PLI scheme for setting up coal gasification plants. For that, some of the things can be done for rationalizing the pricing of the coal for gasification. Because the typical figure I have noticed, last night I was discussing with my friends here, that if you mine the coal in Dankuni, its cost is about, Dankuni is in the Bengal, is in the region of 800. Western coalfield, I think it's about 1200 to 1500. Now, once it goes to the site where this is required to be done, through all the taxations and things like that I have done, the cost becomes 4,500 to 5,000 rupees per ton. Now, this is a very excessive inflation that takes place, which is actually affecting the industry of coal gasification, and the chemicals are becoming non-competitive. So it becomes important that policies for taxation, state cess, and transportation handling should be modified, particularly rail transportation. I got it done from 160 classification to 100, but unfortunately the new minister and new government, management came, and they again went back to 120 or 140. So this kind of a ding-dong will certainly adversely affect the coal gasification plants. And if we want to achieve that 100 million tons target, I think this kind of a support, VGF funding, all of them are absolutely essential. I'm very happy that Vidarbha is organizing a conference of this night twice, and the focus of the government of Maharashtra is totally on exploiting the natural resources of Vidarbha region, the technical capabilities of the people here, and the investment profile what we have. It shall be one of the foremost center for producing coal gasification in the country. I wish you all the best. God bless you. Thank you very much.
Now we will start our panel discussion. I would like to invite Ms. Brar from Ministry of Mines to Ministry of Coal. I kindly invite her to basically enlighten us about the various policies that the government is taking towards encouraging the coal gasification projects all over the world, or all over India, and especially in Vidarbha.
Thank you, Nikhil. First, I want to thank the organizers for taking up such an important subject for this forum, and particularly that it's happening in Vidarbha. I think that's a wonderful initiative, because we look forward to Vidarbha being, it always has been a very important part of the country, and currently also a lot of hopes out of Vidarbha in terms of industrial and overall socio-economic development. So many congratulations to the organizers for taking up such a major initiative, and the fact that we have the force of the Honorable Minister who's from here makes it doubly important in terms of not only relevance, but more relevant to 21st century India. The first presentation done by Dr. Saraswat has, I'm sure, given all of you who are not aware of gasification also a lot of view. And whoever knew a little bit about gasification, I think Dr. Saab's presentation was excellent in terms of various things around gasification. The first thing, and I must add to what he said, that there cannot be any dispute or any debate on the fact, on the need for gasification. And that's why at the central government level, the whole concept came as a mission. So we have a mission called the Coal Gasification Mission, where the target is 100 million tons of coal to be used for gasification by 2030. Now, when we announced the mission, of course, all the challenges that Dr. Saraswat has already pointed out, that where do you go for technology, what do you really do, started to emanate. And a lot of discussions have happened at Niti Aayog level also to see that yes, there is technology around the world, but then how to make it suitable and how to make it relevant to the Indian coal conditions, because obviously every country's coal is unique and so ours is also unique. It has its own positives, it has its own disadvantages on how to use it in the optimal manner. Now, while all these evaluations were happening and while all the discussions were happening at Niti Aayog level, Nikhil, the government in the meantime thought that let's do a few more things. One major thing that came up was the financial support policy, the 8,500 crore that got announced in January 2024, because one clear understanding was that financial support is something that the sector will need. And the government also wanted to show its own seriousness in terms of commitment in supporting the industry. Currently, under that, as already shown in the presentation, 7 projects are underway, and Coal India has taken the lead, because another thought was that if the largest coal company of the country does not take it up, then who else will? So with that thought behind, Coal India today, in partnership with BHEL, GAIL, and the Talcher project was already ongoing, which of course Piyush will talk a little more on in detail. But those are things that we are already taking up. And alongside that, we have New Era. Bala Saab will talk more on that part. And Greta, you're already here. So a lot of interest has already come. While doing that, then the other things that were required was that making sure coal is supplied in abundance. So that has happened. The NRS special window for gasification is already there. In terms of the auction of coal blocks, if you take that, then the revenue that you have to pay to the state government is 50% for gasification. So that's another one of the important policy initiatives. So number of such things. And now when we are looking at technology around the world, if you have to get certain components, so at the Government of India level, you need a clearance called the PPO number 4 clearance. So for 7 different elements, components, let's put it, the approval has come for these 7 projects that are already ongoing. And I'm sure likewise for all other projects that will come in times to come. At the central government level, whenever you need any technology tie-ups, one, you will have the advantage now of already these ongoing 7 projects, their learnings, their transactions, their communications in terms of, yes, technology X, but technology X in the Indian conditions. And that's where I think Coal India, playing its role, a responsible role of taking the lead, is also going to give a lot of learnings. So sessions like these is something we would want that we should have more of them. Because today, after I speak, when Piyush will also come in with his technology part and Bala Saab will also share, these are the forums which will give all of you a lot more information from the ground level, that when the transactions are happening, when discussions are happening with technology providers around the world, how to make the technology suitable in the Indian conditions would be a very relevant part. And in fact, before the sessions, we were having a discussion with Dr. Saab also, and more such panel discussions, more such thought will be undertaken very soon with Niti Aayog at the helm of affairs. So we will be going back to them with all the learnings that have happened in the last few months to make sure that there is convergence, and also any new partner that comes in doesn't have to go through the same baby steps again. All the baby steps that are being taken in these 7 projects will be like a learning for all of you. So a lot of things like that happening at the central government level. We also have our doors open for all of you. You're more than welcome to come and give your suggestions, your problems. I already have a paper given to me by Madhusudanji. So a lot of things are there. Financial support, the government is already working in expanding the current policy, looking at all the interests. And I'm sure in times to come, we will be looking at an expanded scheme also. And in terms of technology, as I already said, there is a lot of dialogue already happening, of which all of you will be the beneficiaries in times to come. What has also emerged out of forums like these, including today, is the need for us to support more innovation, more R&D within the country. Our aim should be over a period of time not to need going out of India to get technology. We should become Atmanirbhar in terms of technology also. And that's where I think my, in fact, request to all of you will be that when the government is coming so actively into it, all of you should also do your small pilots, do little experiments. There is already in the existing scheme also the scope for doing a small pilot, which is one of your projects, in fact. And those kind of initiatives, our goal should not just be 100 million ton by 2030. Our goal should be ingrown indigenous technology by 2030. I think that would be the success. And I'm sure that as a country which is a billion, almost a billion plus actually country today, with the kind of science and technology temperament that we have in our country, if we really set our goal on it, we can do it. I think that should be, I mean, we have on this little forum only, we have somebody who has been celebrated, given so many awards, doctor, and so Padma Bhushan, it's not a small achievement. And then Dr. Saab comes from a different generation. I have a young person here, Nikhil, who's already done his doctorate in gasification. So I think collective wisdom, if we see between all of us here, Piyush, you are there, Dr. Saab is also there. So much of potential in terms of putting our heads together. I think the time for us, and which is where I would want to leave my thought with all of you, is the time for us in India today is we really should start believing in ourselves that we can do it ourselves. थोड़ी सी learning दुनिया से लेके आनी है, because there's no point in wasting time in whatever learning they have done. But after having said that, there is no reason why we should keep depending on technologies out of India. I think that's where we need to come together, and we must use the benefit of all the collective wisdom that is there in our scientists, in the practitioners, in all of you who are associated with the trade to make the policy. Now, while we are talking of one kind, because the one focus today was on surface, I also want to just use this forum for one more dimension, that when we look at India's coal reserves, Nikhil, in 1st April 2025, for example, we have 400 billion tons of coal in India. That's enormous. We are the second largest country in terms of our reserves and also in terms of using coal currently. Out of this, almost 44-45% of our reserve, which is about 175 billion ton, is quite deep-seated. We as a country also need to think about how to use that deep-seated resource. And that is an important dimension on which also we are working in making a framework for underground coal gasification. Again, there have been global studies. There are not too many commercial plants currently. But it's a challenge again for us as a country that can we not do it? With so much of global study available, with pilots done around the world, again, it's a challenge for all of you, the young scientists, the senior ones, and everybody in the practitioners, to put that knowledge together and made a success. Why is it important? Dr. Saab has already highlighted. I want to still add to that. If we look at just 2025, the coal, the chemical that India has imported is a little over 2 lakh, almost 2.5 lakh crore, which is a lot of money spent on importing. And what are we importing? We are importing synthetic natural gas, we are importing ammonium nitrate, and things like that. Things that we can very well get from coal, in the coal to chemical approach. So that's a high priority area, and one, it is important from the government's perspective, of course, to become self-reliant, but it's also a very good business opportunity. For anybody associating today with coal gasification, whether surface or underground, look at the kind of downstream products that are today required in the domestic market itself. And then look at the export potential. It's tremendous. So I think from my forum, I would basically like to exhort on all of you that we should get together, make a success of it. It's a great business vertical. We should look at good partnerships in terms of financial investment, technology partners to begin with, and aim not just to become self-reliant, but to look forward to export these chemicals, which currently as a country we are spending so much in terms of importing it. So I think those are some of my initial thoughts, and also want to leave one more thought with everybody again. We do get a lot of feedback. We do get a lot of you coming to us physically or writing to us. Please keep doing that. Because in the last 1.5 years, the kind of movement seen in gasification has not been seen ever before in India. I'm sure Dr. Saab, you'll agree with that. So I think we need to build on that momentum. We will be very happy to